Hello BTL Advanced students. For today's video, we will be learning all about applications of modular arithmetic. At the end of the discussion, you are expected to apply modular arithmetic in determining ISBN and UPC check digits. Determine a valid card number using modular arithmetic. And encode and decode messages using modular arithmetic. Okay, class, let's tackle first the ISBN and UPC. ISBN, it is an International Standard Book Number. This is a 13-digit number which was created to help ensure that orders for books are filled accurately and that books are cataloged correctly. Okay, remember that ISBN is a 13-digit number. The first three digits of this ISBN are 978 or it could be 979. So, di na pwede ma-usob. Mauna ang first digits, 3 digits sa ISBN. It is followed by 9 digits, which are divided into 3 groups of various lengths. These indicate the country or region, the publisher, and the title of the book. The last digit, the 13th one, is called the check digit. So this one, class, this is the first 3 digits of the ISBN, followed by the 9 digits. So let's count 1, 2, 3, 4, 5, 6, 7, 8, 9. So mauni. And they are divided into 3 groups, diba? 1, 2, 3 of various lengths. So the first group is 1. The second group consists of 4 digits. And the third group is also consists of 4 digits. And this last digit, the 13th one, is what we called the check digit. So if we were to label these digits of ISBN, the first digit is the D sub 1, D sub 2, the second digit, D sub 3, the third digit, up until the last digit, which is D sub 13. Okay. So now we have the formula for the ISBN check digit. So determining the ISBN check digit, we will use this. D sub 13, this is the ISBN check digit. So it is equal to 10 minus D sub 1 plus 3 times D sub 2 plus D sub 3 plus 3 times D sub 4 plus D sub 5 plus 3 times D sub 6 plus D sub 7 plus 3 times D sub 8 plus D sub 9 plus 3 times D sub 10 plus D sub 11 plus 3 times D sub 12 mod 10. So do you notice, class, that the odd digits in the ISBN are as is. So as is na sila. While the even digits, we multiply it by 3. Okay? So if D sub 13 equals 10, then the check digit is equal to 0. Okay, class, let's have an example in determining a check digit for an ISBN. So the first 12 digits of the ISBN are these. And the check digit or the last digit is missing. So we will compute it using the formula, this one. And first step, class, is we need to substitute this D sub 1 plus 3 times D sub 2 up until this 3 times D sub 12 by the digits here, okay? So D sub 1 is 9 plus 3 times D sub 2, 7. So this one plus our D sub 3 is 8 up until we have the D sub 11, which is 2, so here, times 3 times D sub 12, so 3 times 0, okay, mod 10. So I hope you have all gets or you have all understood how we substitute this. So we will only look at the formula, then we will also look here at the digits presented, or the digits, the example digits, okay? So if we are to solve this, adding it all here, so it all came up to 97. So use your calculators, class. 9 plus 3 times 7, 21. 9 plus 21 plus 8 plus 0 plus 7 plus 12 plus 3 plus 6 plus 5 plus 24 plus 2 plus 0. So it is all 97. So we have 10 minus 97 mode 10. Okay. So take note that this mode 10 is already given in the formula, and we will compute this first, 97 mode 10. So recall, class, that if we have this 97 mode 10, we will divide 97 by 10, and let's look at its remainder. So that is the answer. Okay, 97 divided by 10. So the whole number there would be 9, since 9 times 10 is 90, but there's remainder 7, so that is our answer, okay? So 7. So 10 minus 7 equals 3. So the missing number here is 3. Therefore, the check digit is 3. Okay? I hope you were able to follow me, class. Now let's proceed to the UPC, or the Universal Product Code. So it is a 12-digit number that satisfies a modular equation that is similar to the one for ISBNs. So the last digit is still the check digit. So if we were also to label the first digit of an UPC, so D sub 1 is also the first digit, D sub 2 is the second digit, and so on to the 12th digit, which is the D sub 12. So this is the formula for the UPC check digit. So noticing it, class, it is quite the same with the formula for the ISBN check digit. But however, this is up to only 11th digit, since UPC has 12 digits only. And also, here in UPC check digit formula, the odd digits of the UPC are multiplied by 3, and the even digits are as is. Okay, it is quite opposite with the ISBN, since ISBN, the odd digits are as is and the even digits are multiplied by 3. So I hope you were able to follow me, class. So if D sub 12 equals 10, then the check digit is 0. Now let's have an example determining a check digit for a UPC. The first 11 digits of the UPC are this: 02519221221, and the last digit, which is the check digit, is missing. So let's solve it using the formula. So we have this. If we are to substitute this is equal to this. The first digit here is 0, so it is multiplied by 3. The second digit is 2. The third digit here is 5 multiplied by 3, since it is odd. D sub 4 equals 1. D sub 5 times 3, 9 times 3. D sub 6, 2. 3 times D sub 7, 3 times 2. And then D sub 8 is 1, as is. D sub 9 is multiplied by 3, so 3 times 2. D sub 10 is as is 2, and then the D sub 11 is multiplied by 3, is 3 times 1. Okay, mood 10. So, adding it all here, class, we come up with 65. Use your calculators. 3 times 0 is 0 plus 2 plus 15 plus 1 plus 27 plus 2 plus 6 plus 1 plus 6 plus 2 and plus 3. It is equal to 65. Mod 10. And again, if we will solve this, we will divide 65 or we will divide 10 by 65. So 65 divided by 10, the whole number is 6. Since kung mag-divide ta sa 65 divided by 10, di man pwede, di ba? 60 ra. So the whole number is 6. And there's the remainder, which is 5. So that is our answer for this. So 10 minus 5 equals 5. Therefore, the check digit for this UPC is 5. So the last number here is 5. Okay. Now let's proceed to credit card numbers. So class, credit card numbers are normally 13 to 16 digits long. So the first 1 to 6 digits are used to identify the card issuers. So these are some of the identification prefixes used by 4 popular card issuers. So in MasterCard, 51 to 55 with the corresponding number of digits, which is 16. Visa is 4. The number of digits is 13 or 16. And card issuer American Express has prefix of 34 or 37, which is consist of 15 digits. And lastly, Discover prefix is 6011 and the number of digits is 16. Just you notice, class, that different card issuers has different corresponding prefixes with their corresponding number of digits. Now, the LOT algorithm is used to determine whether a credit card number is valid, and it is calculated through this. So beginning with the next to last digit, since after it is before the last digit, right? So the last digit is also the check digit here in the credit card number. And reading from right to left, double every other digit. So if a digit becomes a 2-digit number after being doubled, treat the number as 2 individual digits. And lastly, find the sum of the new list of digits. The final sum must be congruent to 0 mod 10. For this to be a valid credit card number. Now, to better understand this, let's have an example determining a valid credit card number. So let's determine whether this credit card number is a valid credit card number. Okay. So for the solution, we'll use the LOT algorithm. First is we need to highlight every other digit. So beginning with the next to last digit. So as I have said, the next to last digit is the digit before the check digit. So here. So let's highlight this one. This is highlighted. Every other digit is highlighted. So this one also. Then here, there, up to here. So you notice, class, na every other digit ra ang gi-highlight. So next is we need to double each of the highlighted digits. So starting here, 5. So notice, class, na diri tagagikan pag highlight, but then in double we will start here. 5 times 2, so double, 10. 3 times 2, 6. So as is ra ni sila, class, but we need still to copy this one, okay? Karing mga gi-highlight, as is ra na sila, but then we still need to copy this. So 8 times 2, 16. 1 times 2, 2. Up until we get 9 times 2 is 18. Then, add all digits. So we need to add this one. So as you notice, na ay mga double digits gikan pag double na to. Like 5 times 2, 10. So duha na sila ka digits. So we buwagon na sila, but then we still need to add it. Like this 16. buwagon na sila but then i-add gihapon ng digits. And this 18. So, buwagon sila. And now, here. So, from 10, gi1 plus 0, right? Plus 2 plus 6 plus 4 plus, from 16, plus 1 plus 6 na. So, di na nato gi-add nga 16. Ato silang gibuwag, plus 1 plus 6. Up until here, we get the last digit, which is 8. And using your calculators, adding it all, class, we come up to 60. And unsay giingon adtong LAN algorithm, if congruent sa 0 mode 10 ang answer sa pag-add sa tanang digits, if congruent na to 0 mode 10, then the credit card number is valid. So since here in this case, 60 is congruent to 0 mode 10, since if we will divide 60 to 10, so 60 divided by 10, so 6 ang answer, whole number, and y, remainder. So it is congruent to 0 mode 10. So always remember, class, na congruent to 0 mode 10 are those numbers nga makadivide sa 10 since what na remainder. Okay? And that makes the credit card number valid. Now, let's move on to cryptology. So cryptology is the study of making and breaking codes. So before we discuss how messages are coded, we need to define a few terms. Plain text, it is a message before it is coded. So from this example, this line, she walks in beauty like the night. So it is from the Lord Byron's poem, She Walks in Beauty. So this is an example of a plain text. We have cipher text. It is the message after it has been written in code. So from plain text, kung masuwat na siya, kung makode, if makode na ang plain text, cipher text na ang tawag niya. So like this. If this is the plain text, if i-code natin ni class, it will become this text. Okay? And encryption, it is the method of changing from plain text to cipher text. So the process or the method of changing from plain text to cipher text is what we call the encryption. Nja, ang coded text na is the cipher text. Cyclical coding scheme. It is the process of substituting each letter of the alphabet where it is shifted the same number of positions. So like this example, class, as I have presented you the plain text here, and this is the cipher text, right? So, ang process nga pag-substitute nato ani, substitute nato each letter, di ba? As you notice, 3 ra ni ka letter, so 3 sad. 1, 2, 3, 4, 5. 5 letters, 5 sad. This one, 2, 2 sad. So like the follow letters. So, maunay tawag sa pag-process of substitute na each letter sa alphabet. This is called as the cyclical coding scheme. Ang mangutana mo if unsa man na pag-substitute, ma'am. Okay? So we have this table. We have these letters substitute to their corresponding letters. So A, masubstitute if i-code na to. So take note, class, nga kaning nasa babaw, plain text ni sila. Mao ni ang ga-represent sa plain text. And this sa ubos, mao ni ang cipher text. So if this is our plain text, she walks in beauty like the night, then mangita ta each letter sa corresponding ciphertext nila. Okay, so sa S. So we have O, diba? O. So next H. We have D, okay? And for E, A. W, here W sa plain text. S. Sa A, W, ang ilang corresponding ciphertext. So maunahan ton maabot ta ani ang T. So the T ang represent ani is nga ciphertext is P. Okay? I hope nga nasabtan ra ni. Ano so you have noticed nga ma'am naami sa ubos nga namang di kana ang pananglitan kaning W. So ma'am nga namang DA ang iyang corresponding nga ciphertext. So class, as I have said earlier, kaning nasa babaw mauni ang plain text. So meaning ang plain text before na siya ma-code. Kaning naa sa ubos mauni ang ciphertext. So from plain text mauni ang pangitaon nga plain text. So mangita ta sa ilhang ciphertext or i-code na ta sila mauni ang corresponding nga letters. To decrypt a message means to take the ciphertext message and write it in a plain text. If we are to use this message XAWQPU, so the process is sunodon ang gauna nga letter. So for this example, X, so it is followed by Y, Z, and then mabalik na sa A, B. Until the process is the same with the other letters A, B, C, D, E, W, X, Y, Z. So after that Z, we can use again the letter A. Q, R, S, T, U. P, Q, R, S, T. So the same with the U. Sunodon na ta ang letter class until we see or makakita tag familiar word. Okay? So the familiar word here is beauty. So mauni ang plain text from this ciphertext message. And take note nga kapila man ni sila gi shift. So from this message 1, 2, 3, 4. So gi-shift ni into 4 positions until we see the plain text. Now the same with this message, ciphertext message, ODA. So if we are to write it in a plain text, since kimbaw naman ta nga mauni ang take note class nga isa ra ni sila ka line, like how I used this earlier katong she walks in beauty. So since isa ra na sila ka line and we know nga kani nga line uses 4 positions na, then kani mag-use sa ta niya or mag-shift sa ta into 4 positions. Okay? So from letter O, so count 4. P, Q, R, S. So the fourth one is letter S. Okay? The same with letter D. Count 4. E, F, G, H. So the fourth one is the letter H. And also with letter A, count 4, B, C, D, and E. So, mauna ang pag-decrypt sa message, ciphertext message into plain text. Okay? So cyclical encrypting using the alphabet is related to modular arithmetic. We begin with a normal alphabet. So ganiha, gasugod na ta sa mga alphabets. So mauto ang pag-code sa message, pag-decode sa message. Now, pwede na nga ma-associate each letter with a number. So, this table is the numerical equivalents for the letters of the alphabet. So A is 1, B 2, C 3, up until we come up with Y 2. Equivalent niya is 25. But in Z, di na siya 26 class. It is equal to or it is equivalent to 0 rather. Okay? Now, if the encrypting code is to shift each letter of the plaintext message from M positions into ciphertext message, then we will use this congruence. C congruent P plus M mod 26. So P ania is the numerical equivalent of the plaintext letter, and C is the numerical equivalent of the ciphertext letter. So makita nato na sila sa table. M is the number of positions or kapila gi-shift ang letter. And as I have said earlier class, Z is coded as 0 because if we will divide 26 by 26, then the answer is whole number 1. There is no remainder there, so it is congruent to 0 mod 26. Okay. Now, we have an example. So each letter in Lord Byron's poem, so we will use the line, "She walks in beauty like the night" from the Lord Byron's poem. So kani siya nga line shifted, or kani siya nga letter, each letter sa line shifted into 22 positions. Therefore, ang M nga represents sa positions, it is equal to 22. If mag-code ta sa plain text ana ang S from the word she using the congruence. So kadto nga congruence nga C congruent P plus M mod 26 since we will code plain text message para mahimong ciphertext. Okay? So take note class nga kung gikan sa plain text unja mo code ta para ma ciphertext message ang plain text, then this congruence is utilized. Unsa tong P ania? It is the numerical equivalent of the plain text letter. So, ang letter, plain text letter is letter S. Looking at the table, S is in the 19th. So, 19 plus the positions, 22, given in positions class ha. Then the mod, 26. 19 plus 22, 41 mod 26. So we divide 41 by 26. So koan 2 ang whole number there would be 1 rather. And then so subtracting 41 minus 26, since 1 naman ang whole number, there's remainder there is 15. So that would be the answer. So C, mao ni ang ciphertext letter, numerical equivalent of the ciphertext letter. So, since 15 man ang atong numerical equivalent sa ciphertext letter, looking at the table, it is in letter O. The 15th letter is O, thus S is coded as O. Okay? I hope you will be able to follow me, class. Now, once plain text has been converted to ciphertext, there must be a method by which the person receiving the message can return the message to plain text. So, class, ganiha, I have explained you from plain text to ciphertext. Now, ciphertext to plain text. And we will use this congruence. P congruent to C plus N mod 26. Ang P gihapon ania class is the numerical equivalent of the plain text letter. The same with C, the numerical equivalent of the ciphertext letter. Ang N here represents 26 minus M. Ang M, positions. Okay, number of positions. So, we will decode this letter O in ciphertext using the congruence. Kadto nga congruence ang gi-present. Mauni ang gamiton nga congruence kung gikan sa ciphertext, then ato ni siyang i-decode para mahimong plain text. So, using this congruence, C, unsa may numerical equivalent sa ciphertext letter O. So, looking here at our kanang table gihapon, it is in 15th letter. So, 15 na siya, plus 4, nga naman. N is equal to 26 minus M. So, 26 minus 22, using again the positions kanang I have kanang used earlier since this is still in katong example sa Lord Byron's poem. So, the answer is 4. Therefore, the N is equal to 4, then mode 26. 15 plus 4 is 19, mode 26. And if we will divide 19 by 26, it cannot be class. So, as is, we will use this as the answer, this 19. Okay. P is equal to 19. So, pangitaon nato ang plain text letter ana 19. So, letter S. The 19th letter is S, thus O is decoded as S. Okay. So, I hope you have all understand it, class. We have here another example. Use the cyclical alphabetic encrypting code that shifts each letter 11 positions. To code Catherine the Great and decode this TGLY ASP EPP EPCC TMWP. First, let's solve this letter A. Code Catherine the Great. So for the solution, class, the encrypting congruence we will use is katong gikan sa plain text para mahimong ciphertext. So this would be C congruent to P plus M, which is the number of positions given ni ganiha, so 11, mode 26. So replace P by the numerical equivalent of each letter of plain text and determine C. So this will be the congruence nga gamiton. Kung si letter C atong unahon, it is in third letter, plus 11, the position, mode 26, is equal to 14, mode 26. I have said, or it is congruent to 14, mode 26, as I have said, kung di pwede ma-divide, this would be the answer, 14. So if we will look at the table, class, the 14th letter is letter N. Okay, so we can code C as letter N. For the next letter, we have A. C congruent to 1, so the first letter is A. So it is 1 plus 11 positions, mode 26. 1 plus 11, 12, mode 26. So this cannot be, therefore this would be the answer. And in the 12th letter, it is letter L. So we can code A as L. The same with letter T. It is in 20th letter. So 20 ang P niya. Plus 11, mode 26. And this one, pwede na siya makadivide sa 26, right? 31 divided by 26 is equals 1. And there's the remainder, 5. So this is the answer, 5. And then the 5th letter is letter E. So we can code T as E. So the same process na sila, class, until we get the Catherine the Great nga plain text. Kung atoan ang padayunon, we can come up to the ciphertext message, which is this one. NLESPCTYP ESPRCPLE. Take note nga each letter has corresponding kanang ciphertext letter. So, kung pila ka letter si Catherine, the same with this. this tulo ka letter, grade 1, 2, 3, 4, 5 letters. Okay. Now letter B. So if we were to decode this ciphertext message, ato ni siyang i-decode para mahimong plain text message. Okay? So solution, M niya is 11 class, katong positions nga gi-present ganiha. So N, 26 minus M. 26 minus 11, so we have 15. And the ciphertext is decoded using the congruence, katong second congruence, from ciphertext to plain text, P congruent to C plus N. So since N is already 15, so ato na sang i-substitute. Mood 26. So this is the congruence. Kung atang i-decode si TGLY, C congruent to 20, since T is in the 20th letter, plus 15, mode 26, 35 divided by 26, we have 1, and then there's remainder 9, so the answer is equal to 9. And if we were to look in the table, letter number 9, the equivalent letter is I. Okay. So again, G is in 7th letter, plus 15, mode 26, so 7 plus 15 equals 22. This congruent to 22, mode 26, so since 22 cannot divide 26, there it is the answer. In the 22nd letter, we found it is V. L, C congruent to 12 plus 15, since L is in the 12th letter, it is congruent to 27, mode 26, 1, since the remainder is 1. Under the first letter, it is letter A. Take note class nga kinahanglan pangitaon tanawon ang kanang table numerical kanang equivalent, tanawon ang letter nga equivalent ani ang numbers so that we can decode it. And then for the letter Y, since Y is in the 25th letter, then 25 ang ma-represent sa C is equal to 25 plus 15, 40, mode 26, 40 divided by 26, it is 1, and then the remainder is 14. So decode Y. In the 14th letter, it is N. So TGLY can be decoded as Ivan. So continuing process class, itong makuha nato itong kaning kanang ciphertext. I-continue gihapon, parihara gihapon ang process here. So it will, kung ataan ang mahuman, then it will be decoded as Ivan the Terrible. Okay? So parihara ang process anaan nila class. Maura gihapon niga congruence ang gamiton, but then the C depends on the number of the letter. And then maon is then i-decode. Okay? So I hope you have all understood our lesson for today, class. If you have queries, if you have questions, clarifications, don't hesitate to ask me or contact me in my messenger. For your assessment, I want you to answer the following in a 1/2 sheet of paper. So each item corresponds to 10 points. Number 1, determine the correct check digit for the ISBN. 2, determine the correct check digit for the UPC. Okay, so you will use the corresponding formulas for the ISBN check digit and the UPC check digit. For number 3, determine whether the given credit card number is a valid number, and you are to use the LAN algorithm class. For your assignment, you are to research and study in advance Introduction to Graph Theory. Okay, so thank you so much, BTL Ed 1. This will be my last topic, and I hope you have all learned from me as your student teacher in a Mathematics in a Modern World subject. So thank you everyone for your participation and cooperation during our class, and goodbye. Thank you.